Hello everyone and welcome back to the channel. In my last video, we talked about applied statistics in Excel. We saw an introduction to the different types of variables in Excel and how do you describe your data. We saw a look at numerical and categorical variables, and we also saw some summary statistics on numerical variables. If you haven't checked the video, I'll leave a link in the description. This is the part 2 video in the series where we are going to take a deeper look at the measures of central tendency and the measures of dispersion. But before we dive right into it, do not forget to subscribe to my channel for the latest of data analytics across different technologies such as Python and Excel. So let's take a deeper look at it. So first, in the last video we had done the descriptive statistics for this miles per gallon variable, and we found the measures of central tendency, which are nothing but the mean, median and the mode. They tell you something about your data. It is a single value that represents your data. So the miles per gallon, the average value is 20, the median is 19.2, which is nothing but the middle value of your data, and the mode is 21, which is nothing but the most frequently repeated value of your numerical variable. So given these three values together, it would be a fair guess to say that the next best guess for the miles per gallon could be something in the range of 17 to 23, as we discussed in the last video, with 20 or 21 being a good guess. But let's take a look at how outliers affects the measures of central tendency and why it is important to look at the measures of central tendency together. So I'm going to edit this value. Let's say for the Volvo, I'm going to add 2000 as the mileage. Okay, and now let's do the descriptive statistics again and see the effect. Okay, I'm going to go to data, I'm going to select data analysis. Let me click on descriptive statistics. Okay, I will select, let me select the same miles per gallon again. So control shift down and let me give the output range, select here, okay, and click on OK. So again, let us see now what has happened now. Now I've just changed one value. I've added the miles per gallon as 2000. So it is, you can see 2000 fairly differs by a huge amount from these other values. So we can call this as an outlier. It's like an anomalous value because most of the values lie in the range around, as we discussed, from 17 to 23 by looking at the descriptive statistics. So the mean value, now you see it has got skewed. You can see the value, the mean value is 20. Here the mean value is 81.92. So if I would look at the mean alone, so I would now think that my central point of my data, or the next best value, could be around somewhere in the range of 80, 81, but that is completely wrong because it has been skewed because of this outlier. So always remember that the mean value gets affected, or they are influenced by the outliers. But let's take a look at the median value. The median value still remains the same. It was 19.2 here and is 19.2 here. So the median value is not impacted by outliers, as we discussed this in the last video, and we'll see why it is. So now if I were to look at my data, my best guess value still remains around the 17 to 23 range because the mean has been influenced by an outlier or an anomalous value, but the median value still gives a fair representation of the data. So let's take a look at median and see why it is immune to your outliers. Let's copy this variable down. Okay, let's have, this is a very fundamental but a very important understanding how the median is calculated. So now let me just sort this on data and sort it from smallest to largest. And now to calculate the median, so the median is nothing but the middle values that split our data. Okay, so let us see how a median is calculated with a simple example before we calculate the median for the example. So say I have this data 1, 2, 3, 4, 5. I want to find the median of the data. So visually you can see the middle value is 3. Okay, so my median is 3. If I do this median function and I do this, select this, and you can see the median is 3. So the median splits your data. Okay, we can see we have 2 data points above and 2 data points below. So the formula for calculating the median is n plus 1, the number of samples, n plus 1, so 5 plus 1 divided by 2, and that value splits the data. But what happens if I have an even number of data? Then I cannot apply the same formula. I cannot do n plus 1 divided by 2. So I have to find the middle value, that is n divided by 2. Okay, so that means that the n is 6 here, so n divided by 2 is 3, plus I have to find the middle two values. plus the next value. So the next value is n divided by 2 plus 1. So 6 divided by 2 is 3 plus 1 is 4. So the fourth value. Okay. So you can see these two values together now represents the middle portion of your data. It splits again 2 data points above and 2 data points below. So the average of these 2 data points is your median, which will be 3 plus 4 divided by 2, which is 7.5. You can confirm it here, equal to median, and let us select this, and you can see, sorry, let us do it again. Median, you can select this, range, and it is 3.5. Okay, now let us take a look at this data. I'm going to add some counter here. Okay, now let us see here. So you can see there are, okay, let me do this. Okay, so you can see we have 32 values, and again this is an even data set, so the median value would be the 16th and the 17th value. Okay, so n divided by 2 and n divided by 2 plus 1, so the 16th and the 17th value. So if I select these two values together, okay, so you can see these two values splits by data are equally, and therefore the median is the average of these two values, which is 19.2, which we got here, 19.2. Now we can see is this value 2000 doesn't impact this data. If I do the median of this, okay, and I select this, okay, you can see my median is 19.2. If I change this value to even 4000, the middle value of my data, these two data points, the average of that still remain the same. If I put 20 as before, it still remains the same. So the median in this case gives a fair description of my data and how it is distributed, while my mean was skewed due to the outlier. Hence it is very important to see the mean, median and mode together before making a good understanding of your data. And these are called the measures of central tendency. Now let's take a look at the measures of dispersion, that how spread your data is. So the standard deviation gives you the measure of your dispersion. So that means your each data point, the average value at each data point is dispersed from the mean, or the average value of each data point that varies from the mean is around 6.02, and generally for normal distributions around 95% of your data points will be included within 2 standard deviations of your mean. So you can say 90% of your data points will be included between 20 plus 12 and 20 minus 12 in this case. Okay, so this gives you a fair value of your data of your data range, and helps you make a next best guess about your values in the data or understand your data better. I hope you understood this measures of central tendencies and measures of dispersion, because they are very important in statistics. And in the next video I will be making a video on how we can visualize the data. It's very important to visualize the data because some information stands out more quickly than having to read through this. So visualizing this data and understanding these values of dispersion and central tendencies will help you understand more values of your data, along with the range, minimum and maximum value. They can quickly be summarized in a data. So stay tuned for the next video as well. I hope you like this video. If you did enjoy this video, do leave a comment and a like on the video, and don't forget to subscribe to my channel for the latest of data analytics across different technologies. Thank you.